Hello, everyone. A very happy new year to all of you joined here. I'm Sharon. I'll be your presenter. This will be an overview session on big data analytics. Why is it important? And what do we do using the huge data that we collect? So I'll just walk you quickly through it. So today's agenda is what is big data and how do we say that a data can be categorized as big data, and how do we see big data as an opportunity, and what are the practical difficulties that we have in encasing the opportunity or to make use of the opportunity properly, and what are the solutions that we have. And we will also look at what can Hadoop do as a solution, and what does Hadoop ecosystem consist of. That is, when we talk about Hadoop, it is not just one product, it is an ecosystem of different products. So we will look at what are the different aspects of Hadoop and what are the different components of Hadoop that can help you, solve your problems, solve your big data problems. All right. So that's about the agenda for the day. So let us start with what is big data. Okay, so what is the definition here? Big data is the term for collection of data sets so large and complex that it becomes difficult to process using on-hand database system tools or traditional data processing applications. It's a collection of data sets. You just say it's a huge collection of data, maybe. Big data, if you say big data, data is huge, data is big, so it is just the term, as the name says, a collection of data sets that is so large and complex. So it's not only large, but it's of complex. Why is it complex? Because it comes in different types. So it had some relational data, non-relational, unstructured. Okay, so many types of data. So it could be structured, it could be unstructured, it could be semi-structured, and so on. So when all these types of different data gets mixed up, and when it's available for you, it's very difficult to process using the existing database system tools. Why? Because database system tools are usually for relational data. We do have some systems where you can get complex data, but the processing is indeed expensive if you are using your traditional databases. It is very expensive when the data grows. Okay, so we will look at how the data would be growing and how we can manage all that. All right, so that is the difficulty. So big data is just bulk data or large data which is very complex, and you cannot handle it with your existing system, to put it in simple words. All right, I hope you understand. Now let me walk you through the 5 V's of big data. See, these are the characteristics. So if I say my data falls under big data category, then it should actually satisfy these 5 V's. So it could be also taken as the characteristics or how it behaves and stuff like that. All right. The first V is volume. All right. First V is volume. So here is a survey which says by 2020, accumulated digital universe of data will grow from 4.4 zettabytes today to around 44 zettabytes or 44 trillion gigabytes. So of course, it has come true today. We have ended 2020 already and the data is growing and growing. All right, so the volume of data, the volume of this huge, large, and raw data keeps growing. All right, so when the data grows from 4.4 zettabyte to 44 zettabyte, imagine whether your system would be able to take it just like that. You need separate technology, you need separate storage, and you have to find an optimal alternative for your data to store your data. If you see, I hope most of you would be using your Gmail, your iCloud, okay, and whatnot. So if you see, they give only a few gigabytes as free. If you want to store more data, you need to buy some space in their cloud, either in Google Cloud or in your iCloud. Okay, or you have to pay in order to keep your data in a commonly shared space. So this is This is just for a personal data. For one person itself, the data is growing so much. So imagine the volume that would be accumulated for a large organization, for an academic institution, for banks, whatnot. All right, so this is the first V that we say that our data is big. All right. Second V is variety. Variety is, as I told you already, the different types of data. Okay, the data doesn't come only in your text format, or it doesn't come only in, you know, kind of bytes. It doesn't come in a number format. It doesn't come only in a graph format. It could be a mix of all different types of data. All right, that we call it as variety. All right. So different kinds of data is being generated from various sources. So as I told you, we categorize the data into structured, semi-structured, and unstructured data. All right. So some sources generate structured data. So a good example for this is your HR system, your company's employee management system, or something like that, where your data is all organized in a proper format. That we call it as structured. And next comes the semi-structured data. So semi-structured data, no, it doesn't fall under either the unstructured category or the structured category, because it is partially structured or semi-structured. A good example is your email. If you take your email, you you open your mail. For example, if you have received an email, just like that, you cannot find any information out of it, or you cannot take anything out of it. You have to open the mail, and then you have to categorize it into the head, which has the mail address, from to, and then the subject. So that will be in your header part, and then comes the body of the message, and then comes the other encryption, or if there is any attachment, and all those things. So you have to open the mail, and then you have to do some processing on it in order to get the information that you want from your mail. Just like that, you cannot, as you open a table and take the data you want, you cannot do it in your mail. Same thing goes with your JSON format, XML, TSV, okay, and CSV, the comma separated format. So whatever, so these all need some processing. You don't have to process completely, but the data is partially organized, and you need to do some layering on top of it in order to get some meaning out of it. So this is the semi-structured option. And then comes the most challenging part, unstructured. So unstructured data, if you take, as you can see some examples here, the log files, audio files, video files, images, blogs, okay, a lot of files. For example, if you take your Twitter tweets, and the tweets can be, you can have a certain limit for the tweets, and you can it could be retweeted ones, and you will have some timestamp on it. So if you take a tweet, you cannot just like that process it. You need to do some kind of filtering out of it, and then you have to do, if you take the log files, imagine the, if you take any e-commerce website, it will be logging each and every click of yours. If you are going to purchase something, let me take an example of, I'm trying to find which phone is better. Okay, so I go and I go to a e-shopping website, and I just navigate to the phone section, and then I go and click on the particular brand that I want, the model that I want, and I go through the reviews, and then I come back, I compare it with the other phones. I do so many things before buying. All the clicks that I make are being recorded or being taken. So it goes into the log files. So imagine for each of your click, there is a log that is getting generated with the timestamp from the IP address where you are accessing, and which page where you're accessing, and everything. So how much information would be there in the log file? Is it easy to use the log file as it is? No, you need to process the log and filter to find which page I was looking at, and which product I was looking at, and then to find whether I have purchased the product or whether I didn't purchase. And these logs are also part of making the business better. So we will look at it in the upcoming slides as well. All right. So this is the variety part. So the different types of data are generated from different sources, and these data form as huge or big. Okay. The next V, it's a very important V, velocity. This is the real challenge, I would say. Velocity, you know that it is the speed of how the data flows. Social media. Take the example of Instagram. So as we speak now, in Instagram, how many people would be posting? How many people would be posting the pictures, videos, reels, or whatever? How many people would be posting stories? So within this second, this minute we are speaking, you can see that so many internet activities are being happening. So as you can see here in this example, every 60 seconds, 1 lakh plus tweets, and in Facebook you have 6 lakhs and 95,000 status updates. And you can see similarly for all the other one, how many Google searches, emails, how many terabyte of data is created. You can see that in 1 minute there are 217 plus new mobile users. So you can see that you can categorize it into the different options on their usage. So this is social media alone. Okay. But when they have to store the data, imagine how much data is getting populated. So it's very difficult to process the data if the data comes in such speed, if bulk data is coming in such speed. All right. So this is the third V, velocity, the speed in which the data flows in into different social media space. Or if you want me to give another example, I can give you an example of the sensor data. If you take the sensor data, let me take an example of a car manufacturing company. So let us assume that the complete car manufacturing process is automated. Okay. And if you take it as automated, then for each and every step of assembling the car, you do a test. I mean, you do a quality test, and all the data is getting stored. And each and every stage when the car comes by, the sensor takes the information and it stores whether it is whether the units were assembled properly, whether it is passed or whether it is failed, and so many things. And if there is some issue, then what happens? You have to process the sensor information and then you have to take the data. So this is also very crucial for the company in order to monitor, in order to track how the manufacturing is being done. All right. So the data has to be handled as and when it comes. Okay, that is very important here. Okay, so this means the velocity. The fourth V is the value. Value is the mechanism to bring the correct meaning out of the data. So as I already told you, let us take the same Twitter example. There are a lot of tweets available. All right. So if you are working for a company and people are tweeting good about your company and bad about your company, you have to find which comments, which tweets are really important and which tweets can be ignored. So for that, you need to do some processing. That mechanism is actually challenging when the data is huge. All right. So you need to first filter the data, as you can see in this picture, and then you have to remove the unwanted data and then do some processing on it and then derive out a value. So what I'm trying to say here is, as you see the data, it doesn't make any sense. Okay, you need to do some processing in order to get some value out of it. Okay, so that is what is value. So when you see the big data as it is very difficult for you to immediately process it. You need to do these steps in order to process the data and bring some value out of it. So this is the fourth V. And next to value, the final V or the fifth V is the veracity. Veracity is finding the truthfulness of the data. Okay, so as you see here, there could be uncertainty and inconsistencies in your data. So if you see here, you can see that this is a table and you have value for minimum, but you don't have a value for maximum. And you don't have a value for mean here, but you have for standard deviation. So some data is missing and some data is inconsistent. If you see here, it's 4.3, 2.0, but here it suddenly is 15,000. And here it is different, it's a large digit. So there are so much of inconsistencies in the data that is raw. So we need to process in order to find the truthfulness of the data, and we have to make sure that the unnecessary data is removed and only the proper consistent data is available. So these are the 5 V's of big data, which makes it big data. All right, so basically the characteristics, I would say. Or when if I'm trying to find a big data solution, I should make sure that it addresses all of these 5 V's. Okay, so we saw the different characteristics of big data, and based on which we had categorized the 4 V's. And now let us look at how big data can be seen as an opportunity. We discussed that it is huge, it is of large volume, and it comes in different forms, different data types, and it comes in different speed, and and the value or how you're going to process is different. So we saw all that. And keeping all this in mind, how can we say big data as an opportunity? Let us look at it. So here is when big data analytics comes into picture. All right, so if you properly analyze the big data, okay, which has all those 4 V's, the characteristics, if you properly analyze, then you can actually be able to make a lot of money out of it, and you can get a lot of trends and get different insights, okay, and many more opportunities. So if you see here, let me come from the first one: automated car, healthcare, etc. Okay, this could be the first case. You can come up with next generation products if you are able to handle your big data properly, if you are able to analyze properly. How can you do that? Okay, I was explaining about an automated car manufacturing. So let me tell you about healthcare. In healthcare, if you see, there are a lot of sensor based, chip based, the facilities getting nowadays popular. Okay, not much in India, but in many countries they have already implemented. Okay, so what happens is, if I'm consulting a cardiologist, and imagine that I have undergone a surgery recently, and there is a chip that has been implanted. Okay, and that chip would actually when connected to my Wi-Fi or something, so what would happen, what it would do is to actually alert the cardiologist if my heart malfunctions, or if there is any kind of heartbeats irregular, or if some threat is there in my body. Okay, so I'm not getting into the chip technology and all, but I'm just telling you an example. So what happens here is, the doctor could be having an app, and that app would actually give a notification or alert telling that, hey, your patient, so Sharon, is actually her heartbeat is not regular, it's actually skipping a bit, and it's more than the normal, or it is less than the normal, or something. If there is some variance, it would immediately update, and maybe I will get a call from my doctor or the concerned hospital to come for a checkup. So life would be easier, right? So without me finding it, my data gives them. So how is it possible? How can they send a notification immediately? How can they do it? Because they take the heartbeats. Okay, they constantly take how my heartbeat is. Okay, so all the data is getting dumped, my health information. Like I'm just telling you an example of the cardio related stuff, and it could be something related to other organ functioning as well. So when they get data continuously, and when there is some change, some variation in the data, then immediately, if there is some analytics implemented there, immediately the threshold would be found, and they will be immediately finding it and contacting me. So This is the next gen products in healthcare. And in so many places, they are using chips for many reasons. It could be for the government related ones, it could be for the defense related, and so many things are there. But in healthcare, when you're able to analyze the data properly and see my heartbeat, how much of heartbeats would be there for one person, and how many patients information could be stored. Okay, so for this you cannot just use your database to do it, because you don't need every heartbeat. You need only the varying heartbeat. I hope you get the difference. So based on that only, you will be able to find what exactly went wrong, and you can give a better treatment and try to save a person sometimes as well. Or you can find the location and you can you can call 911, or you can call the ambulance or whatever it is. Okay, so this actually helps a lot in healthcare. Okay, so if you have to implement such products, you need to analyze that data that you have in bulk. For many people, the health information has to be processed, and then you have to map it with a threshold. You have to map it, for example, the test results. The test result should be in some, for example, the hemoglobin level should be more than 11, or it should be less than 15, something like that. You have to set, and you have to monitor, and you have to match it with the test reports, and so many other things as well. Okay, so this is just one example. Okay, and the next one is cost reduction. So if you use big data wisely, you can reduce your costs. It's a cost effective storage system for huge data sets. So you need to make sure that you have a proper storage system in order to store your large data. As I already told you, it is very expensive to store big data in your existing RDBMS. Let me take the example of Oracle database. You have a license for Oracle database cloud, let me assume, or you do have a Oracle database server, or it could be in MySQL server as well, or MS SQL server, or IBM DB2, or whatever. Okay, so if you have a server, there is a limit for the server, for the storage capacity. But here in the big data case, the data keeps getting generated, and the data has to be processed so often. So in that case, you cannot so often read and write data to and from database. It's very expensive, and it's time consuming as well, and it increases the CPU, and it increases the data traffic. Okay, so it is actually not a good solution for your big data. So you should have a combination of your RDBMS along with something new. All right. So you have to reduce the cost here. Otherwise, your big data will make your system more expensive, and the data read and data write is going to be affecting your organization. All right. So you have to do some cost reduction by kind of adapting to some new technology to store this data and process it in a better way. Okay. And one more thing, if you are a database person, I want to make it clear to you that big data or whatever it is not going to replace your RDBMS. Of course, RDBMS is so powerful and nothing can replace it. But here we would be doing a combination of what goes into which system. All right. So that is the next section, I would say. Okay. And next one, faster and better decision making. Provides ways to analyze information quickly and make decisions. So when you choose to store your data properly, your processing is better. Your large data has to be processed separately, and your normal data or your structured data could be processed separately. And based on the nature of the requirement, you can choose to use the analytic tools, and you can also analyze using your existing data analytic tools as well. You can combine that along with your big data tools. So this helps you to analyze properly and take better decisions. Okay, so when you properly store your data, and when store your big data, I mean, and when you properly segregate the data based on the nature of the data, it makes it easier to analyze properly. And the next one is improved services or products. So when you evaluate the customer needs, okay, and find whether they are satisfied or not, this is another opportunity. So as I told you, seeing the tweets, okay, let me take the example of an travels company. Okay, so if a travels company wants to find why the reviews are negative, and who have given negative reviews, and how many people are followers of that person, and who gave positive reviews, and what went well, what went wrong, so all that you can see using the different reviews posted, maybe the Google reviews, the Facebook reviews, and people who are posting, tagging the particular company. Okay, so this could either take your company in a positive note, or it could actually, bring your business down as well. So you have to make sure that finding the customer satisfaction is present, is important. All right, and you have to find what the customer wants. Why is my competitor doing better than me? And what is my competitor's products options are, like whether I can be able to implement such things, is it feasible? So you can take business decisions. All right, and apart from these four opportunities, we do have a lot of opportunities which are there, and based on that you can actually find which product is better, and how I can make use of the opportunity and implement a better data solution. So for that only we need big data analytics. Okay, so let us quickly get into how we can make sure that these opportunities are taken properly. So let us look at what are the problems that we have with encasing the opportunity, or trying to take these opportunities and implement it. All right, so what are the problems that we have? Okay, the first problem that we have is storing exponentially growing huge data sets. This I already told you. Okay, you have a large data set, and for example, if your storage is limited to some 10 petabytes, okay, you cannot assume that the data will always be falling under 10 petabytes. What if one day the data is suddenly more? Like, one example for this is the festivals sales that we have, the online sales. So the website traffic is more than you predict. All right, and sometimes you're not able to place your order as a user, as a customer, and sometimes the company will not be handle the lot of traffic that they get, and a lot of people who are visiting the websites and who are trying to find the products, and in so many previous the great festivals and all, when they had the great online festivals, there were so many issues that happened, which actually spoiled the entire business of few famous e-shoppers. Okay, so we have to store the growing huge data sets. Okay, so it becomes a great challenge. You have to make sure that the data is growing, properly, like it suddenly doesn't grow more and it is consistent. So we cannot predict that, but we should make sure that our system is capable enough to handle the traffic. All right, so the same example that we saw in the initial volume slide, so that is only given here. Data generated in past 2 years is more than the previous history in total. So imagine if we are not ready to save or store all the data properly, we would be the losers. We would be not able to properly analyze it. All right. So by 2020, 1.7 MB of new info will be created every second for every person. I'm sure it's more than that. All right, so this data storing is practically difficult. All right, you have to make sure that you have a system using which you can store your data, which is like kind of dumping the data, I would say. As and when the data comes in, you have to first dump it and then make sure which data you want and which data you don't want, rather than missing to store the data. When you miss to store all the growing information, you will be losing some really valuable data. So this is the first problem, storing exponentially growing huge data sets. So as the picture depicts, trying to just fit in an elephant in a refrigerator, it's impossible, right? So the second problem is processing data having complex structure. So this was the one that we were talking about, the variety. When the data is of different variety, we saw that it was unstructured, structured, and semi-structured. Okay, so when the data is having a complex structure, processing the data is very difficult. All right, so what is it? So when you take structured data, the data is in an organized format. Okay, so data schema is fixed. There is a structure to it. Example is RDBMS data. So if you see, you have the data properly arranged in rows and columns, and you can identify the data based on how it is stored and based on the particular schema. For example, all the HR related data would be stored under the HR schema, and the accounting details could be stored under the account schema. So you have a proper organized data format in the structured one. So this is a simple thing. Okay, when the data is in a proper structure, it is it becomes quite easy to process or simpler to process because you have it all there. But coming to the next two, which are probably a bit complex. Semi-structured, as I told you, it is partially organized, lacks the formal structure, example XML, JSON, etc. So what do we do here in the semi-structured data? You have to convert it to structured information. You have to convert it to structured information, and then you have to process using the structured data processing engines or your RDBMS. So one good example is even in Oracle database, you can store the data in XML format, and you have the option of taking the XML and processing the XML using some XML queries. XML querying is there, but again, that that is possible only for a limited data. When it comes to data which grows and grows and grows, it is very expensive to put it in your Oracle database or any other RDBMS and store it and process it. All right. So you need to find a solution. Sorry. Okay. So you need to find a proper solution where you can process the semi-structured data. Okay. So here comes the NoSQL databases. NoSQL databases are the not only SQL databases. So NoSQL are schemaless. Okay, when it is schemaless, what happens is you can store the data which comes in a semi-structured format like XML, JSON. So you can store the data in your NoSQL, and it comes of different data models. In structured, usually it is RDBMS model or relational model, or you can also call it as the tabular model. But here you do have, based on your type of data, you can store it in columns, you can store it as a document, okay, you can store it in graphs, okay, and so many other options are also available. So depending on the nature of your data, you can choose to use the NoSQL database that you want. This NoSQL database is mostly open source, and based on the category of data you want, you can use, and it tries to hide the complexity from you and helps you to process the semi-structured data in a better way. Okay, so this is the second problem. So you have to make sure that you have something different to process your semi-structured data. And third one is the most challenging, unstructured data. It's totally unorganized and it has unknown schema. There is no proper schema or structure to it. So example, we have already seen the social media information, the multimedia files, audio, video. And one best example for unstructured file is the CCTV footages. Your CCTV footages that you have. You have a lot of CCTV footages for every organization, and even in different apartment complexes you have. And data is constantly getting generated with the timestamp, with the location, and it's all huge video files with audio as well. So what happens, you cannot just like that throw the information away, because it's very important to have the entire footages recorded. All right. And can you make any meaning out of it just like that? No, you have to do some video processing in order to get some meaning out of the video. You have to do some multimedia processing. You have to make sure that voice processing is done or something is done in order to do. So unstructured data as it is cannot make any value. You need to do some processing on it. Okay. So these are the challenges in processing the data that has complex structure. The problem 3, processing data faster. So we saw that the data has to be processed, because as it is, the unstructured data or the complex data cannot be used. All right. So when it comes to processing data, the next challenge or problem is processing it faster. Okay. So processing can take its own sweet time because of the huge data. All right. So data is growing at much faster rate than that of disk read and write speed, and bringing huge amount of data to computation unit becomes a bottleneck. Okay, so let me just try to show you. I'll quickly draw something. Okay, so you can see that the hard disk capacity and the disk transfer performance improvement is different. All right, you see here the capacity and how the transfer rate is actually. Okay. Okay, it is a very mild improvement, and but the data is growing so much. The capacity is so much, but the transfer rate and how it is being processed is actually very less. Okay, and the next bottleneck is bringing the data to computation. So please remember this, bringing the data to computation. All right. So you have master, you have slaves, or you can say as client server. All right. So what happens is the server is in the center. So let me take this as a server, and these are the clients. Okay, client 1, client 2, and so on. Okay. So this one server has to serve all the clients. Okay, slave A to slave E. This one master has to serve. So if all these processing gets into one server, the server becomes really slow. Sometimes it crashes. Okay. So when does it doesn't when it doesn't crash? When the data is in a handleable amount. Okay. But when you take this huge amount of data, definitely this is not a wise solution. You cannot have one master to serve all the slaves, or you cannot actually make sure that there is only one server and you have n number of the other nodes connecting to it. This becomes a really difficult thing when it comes to huge amount of data. It becomes a bottleneck. Imagine if there is if slave B fails, it's still okay because the other slaves are getting their works done. Okay. But imagine if something happens to the master. If the master fails, what happens? The work of all these slaves goes for a toss. So this is a bottleneck. So processing the data cannot be faster because the first in, first out, and there are some concepts, right? So based on the priority, okay, based on the priority of the process, it allocates, the CPU allocates, the OS allocates. Okay, based on the nature of the task, it takes its own time. So you cannot make sure that it's done quicker. Okay, so this is the challenge in processing the data faster when it comes to big data. Now, we have to see how we can actually bring all these problems and change it to different solutions. So now we saw all the problems. Now, the solution for all these problems is Hadoop. So, how can Hadoop be used as a solution for all the problems we were discussing so far? Let us look at it. So, what is Hadoop firstly? Hadoop is a framework that allows us to store and process large data sets in parallel and distributed fashion. So, to explain it further, it is an open source framework which is used for parallel and distributed computing, where you can store and process large data sets at the same time. That is the beauty of Hadoop. All right. So it is not one particular software. It is a framework. Okay. It is a framework and it allows us to store and process large data sets. Okay, and it helps you to do it in parallel as well, which was the third one, the third challenge that we saw, that the data cannot be processed faster because if you have a one master and many slave architecture, then it would be serving one by one only. But here, if you see here, it is doing everything in parallel and in a distributed manner. So what is distributed computing? You know that the data is distributed across the different servers and then the processing happens parallelly, right? So something like that. So how does Hadoop solve a problem? The main two components are HDFS and MapReduce, which are part of Hadoop, which helps us to kind of solve major big data problems. All right. HDFS is Hadoop Distributed File System, which is Hadoop storage system. As the name implies, it is a file system and it is not a database. All right. So it is a file system like your Windows file system or your Linux file system. It is also a file system, but it is a Hadoop distributed file system wherein the data is distributed. The data is not stored in only one place. It is distributed. All right. So because of its distributed nature, it allows to dump any kind of data across the cluster. Cluster is the group of servers, right? So you can dump any kind of data across the cluster using HDFS. So the connected servers can actually share the storage, all right? And this is to store the data. And how do I process the data in a distributed manner? Processing is done using MapReduce. So MapReduce is used for parallel processing of data that is stored in HDFS. So I have my data in HDFS. If I have to do some processing on HDFS, I have to use MapReduce to do it. Now, let me explain you further on how this helps you to solve the problems. All right. So two things to keep in mind now. Hadoop is a framework which allows to store and process large data sets in parallel and distributed fashion. And this storing is using HDFS and this processing is using MapReduce. All right, so moving to the next slide. Let us look at HDFS. HDFS creates a level of abstraction over the resources from where we can see the whole HDFS as a single unit. Okay, so it creates a level of abstraction. So what it means, let me just quickly take my pen. Okay. You don't have to worry about the resources that is there. You don't have to worry about the resources. Okay. You have to just make sure that the data is stored in HDFS. Okay. So if you see here, here also you have a master slave architecture. Name node is the master node. Okay, as it is mentioned, every HDFS, when you talk about Hadoop distributed file system, it has one name node and it has many data nodes. Okay, so name node is the main node or the master node which contains metadata about the data stored. So if you are aware of database, you will be aware of metadata as well. Metadata is just data about data. All right. So when I tell data about data, what data that is present in the name node? It means information about the data that is stored. So for example, this is a data node. Okay. So in the data node, these data is stored. Okay, and data is stored in blocks in HDFS. Okay, so assume this is block 1 and this is block 2 and this is block 3. Okay, so name node contains information of what data is present in block 3, what data is present in block 2, and what data is present in block 1, and so on. All right, so it doesn't store the data, but it knows what information is in what node or what server. All right, so this is the use of name node. It acts as the master, and data is stored on the data nodes, which are commodity hardware in the distributed environment. So commodity hardware means you don't have any specific limit of storing your limit of, like, see, this is how you should install. Only if you install this, Hadoop will work. Nothing like that. In Hadoop will work on your laptop as well, and it will work on your mainframe server as well. Okay, so it is just that you choose where you are going to physically store your data. Okay, that is why it is mentioned as commodity hardware. So depending on your organization's capacity and depending on the data that is being stored, you can choose to have a proper configuration of your servers or data nodes. Okay, for example, I will be getting every day, I will be getting 1 terabyte of data. So if I get 1 terabyte every day, I need to have some 10 petabytes of storage so that I don't lose any information. So periodically you can cleanse it, that is different, but based on that you have to identify. Okay, and as I told you, for 1 terabyte also you can set your server, and you can set it for 10 petabytes as well. All right, it works the same even if you are storing data in GBs. The working is still the same. All right, so you have to make sure that the hardware is powerful because of the data that is coming in. You have to make sure that you have a proper system setup available in order to install HDFS and in order to make a better use of it. All right, so data is stored on the data nodes, and the information on what data is stored where is stored in the name node. All right, so that is about the master slave architecture. But if you remember the diagram of the previous master slave architecture, you saw that it was like the different machines that were around one server. Okay, so it was something like this. Remember? Now it's all totally distributed. See, this is not dependent on this. This is not dependent on this. This is not dependent. And the processing is done on top of the data node here. The processing is not done in the name node. That is the difference. The data is distributed. The processing is also distributed. Okay. So one beauty of Hadoop is data localization. Okay. That is computing the data from where the data is stored. So if my data is in A, I can process the data in A itself. I don't have to take A to C in order to process my information. Whatever data is present in A node can be processed here. So I can store the data in, as I told you, I can store the data in HDFS here, 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 here distributedly. And the next step is I can also do some processing there. So let me tell you how we can do that as well. Okay. Let me quickly erase my drawings and get back to the normal mode. All right. Okay, so what is the solution of storing data using HDFS? The first problem we saw was storing exponentially growing huge data sets. So the solution is HDFS. As I told you, it is the storage unit of Hadoop. It's distributed. And how does it store the data? It divides the files into smaller chunks and stores it across the cluster. So this is an example typically given here. And usually we don't store in MB, we store in div TBs and GBs at least. Okay. So usually of data is stored in blocks. One block is 128 MB. Okay. So data is stored in blocks and one block is 128 MB. Okay. So if you have a 512 MB file, it could be in 4 blocks. Usually we have larger files. That's what I meant. Usually we have larger files where it is stored in multiple blocks. All right. So this file can be segregated based on the 128 MBs it has. Okay. So for example, if you do have a 1024 MB file, then again you will have 8 such blocks. Okay. So based on the size of the file, the number of blocks will be increasing. All right. So it is scalable as per the requirement. That's what I was trying to tell you as well. Based on your data requirement, you can scale as and when your data grows. For example, if you have four data nodes and if it is not sufficient, without much trouble in installation, you can add few more servers to it. Adding new servers in Hadoop is not at all an issue at all. You can just add one by one and you can start working on it. You can start processing. You can add it along with a group of your data nodes and you can work on it. So that way, storing exponentially growing huge data sets is no more a problem when you have HDFS. Okay. So the next problem we saw was storing unstructured data. So here the solution is HDFS again because HDFS is Hadoop storage. So how can I say that this problem can be handled here is because HDFS is a file system. A file system usually follows the worm structure, that is write once and read many. So what happens is when the data comes in, I can actually, let me explain to you. So this is my HDFS. Okay. So when the data comes in, first it goes here and then it goes here and then it goes here and it goes on. As and when the data comes in, it is not inserted somewhere like your database table. It is getting appended to the last one. Okay. So if if I have to insert some data, I have to insert only at the end. I cannot put somewhere here. That is the nature of your file system, right? So you can actually store, when you store it as different files, you cannot just suddenly go to one particular file and you can merge or you can edit that file. That is not possible. Okay. So here literally the data is getting dumped. It is not getting stored like you are storing in your database table. So when you are, how do you insert in a database table? You give an insert statement, right? So for that you should know the nature of your table. You should know while creating the table what data types you have mentioned and what is the size of each field. Okay, so if I have 4 digits, I can use integer. If I have more than 4 digits, I should use long or some big int or something. If I give some long number and if my data type is integer, then it won't allow me to store. If I give the proper data size and the type properly, I can actually store it here. Okay, and while inserting also, it is pretty simple. I have to just say insert into this table, this particular column, this particular value, replace this with this, edit this. So all these things I can give. This can be done only for my RDBMS. But when it comes to HDFS, you can just dump it and you cannot do insert in between. You can either delete the entire block and replace it. Okay, there are so many mechanisms like that. Okay, so that is the HDFS for you. So storing unstructured data is pretty easy because it just dumps the data as and when it comes. So imagine the Twitter data coming in. All the tweets will be stored just like that, one by one, one by one, one by one. And some 1,000 tweets can be falling under one block and another 1,000 tweets in the other block. So one by one it will be. It is not stored in a proper table, but they can process, the system can process one by one, the blocks one by one, and then the data can be processed. All right. So there is no schema validation or structure validation done while dumping the data. Whatever data comes in, it just like that dumps. And then while processing, you take the dumps of data and then you do the processing based on the nature of the data. So storing unstructured data is simple by using HDFS because we are storing it in a file system. So file system doesn't care what data comes in. It doesn't check if the data is in number format, if the data is in JSON format or whatnot. So it is actually easy to take the data and put it inside or dump it inside your HDFS. All right. So third and the main processing problem I was explaining to you, Hadoop MapReduce. MapReduce, as we saw in the initial Hadoop slide, when I say Hadoop, it uses HDFS for storing and MapReduce for processing. All right. So MapReduce allows you to process data in parallel. Okay. So the data should be present in HDFS in order to process it. Okay. Let me again draw something for you. Okay. Okay, so the data, imagine that the data is across different nodes. So when the data is across different nodes, when I talk about the processing, MapReduce can be initiated for all the nodes at the same time. The master node, what the master node can do is, it can ask the data nodes to process the data. Okay, so when it comes to processing the data, it actually takes the data from its local HDFS and then processes. So to give it in a bigger picture, every node, okay, so this is a node I told. If I take it as a node, this node has two parts. It has HDFS installed in it and it also has MapReduce installed in it. So when all the data nodes have HDFS and MapReduce in it, it can take the data from HDFS and process in the same local node. So that's why I told data localization, that the processing is brought to where the data is stored rather than taking all the data to some server to process. So this is a great advantage. And when it comes to large processing of data, large data analytics, you can actually do it in parallel within quick time, within a shorter time. So that is what I told, data locally, the data localization concept. It allows you to process data locally, that each node works with a part of data which is stored on it. Sometimes, if required, it can communicate with the name node if it needs data from the other node. And the name node will take the request and take the required data from the other node. But otherwise, mostly it is the data localization. So this solves all the three problems. So coming to the Hadoop ecosystem. So I told Hadoop framework has a lot of components in it. All right. So in Hadoop ecosystem, you have so many products. As you can see here, you have MapReduce. Okay. You can see that MapReduce is processing and you have HDFS for storage. Okay. As you can see here. And apart from that, there are so many products. I told you that you need to analyze the data, you need to process the data, right? So for this, you have so many products available. Okay, so MapReduce is to do the processing. Okay, so this MapReduce is based on the Google MapReduce algorithm. All right, and it actually maps and reduces the data, and then you get the proper result. Okay, and then you have Hive. Okay, and drill. So these are all used for querying. Okay, so Hive has something called HQL, that is Hive Query Language, which is very similar to your SQL. And you can actually take the data which is stored in your HDFS, and you can do some query on top of it in order to organize the data and filter the data. Okay, so if I have so many tweets dumped, okay, what I can do is I can actually organize the tweets based on the type in a table. I can say um, this is a processed tweets, means I can say I can take only December's information in one table, or based on the timestamp, okay, based on the tweet, the person who tweeted and all that. I can create tables or something similar to tables using Hive. I can create Hive tables, okay, and I can project the data in an organized format, in a structured format, to be make it to make it specific. So this option is available using Hive. So Hive allows you to organize your unstructured data to a proper structure. So in this case, it is a relational structure. All right. And Mahout is for your machine learning, and Spark mlib is also for your machine learning. So you have if you want to process using Spark, actually it is much faster than your MapReduce processing, because it has an abstract MapReduce inbuilt in it. Okay, and so this is one option for you to process your data. And Pig is also a scripting option available for you. It's a scripting language. Pig Latin is a scripting language that is also part of your Hadoop ecosystem. Okay, and you can actually create relations and generate different relations from existing relations. So something similar to Hive, but instead of queries, you will be writing the programming statements. So that is the use of Pig. Okay, so these are all the different components that are available. Okay, and yet these can be integrated in order to make better use. And I was talking to you about NoSQL database. HBase is Hadoop's NoSQL database, which means Hadoop also can have a database on top of HDFS, that is your HBase. Okay, so it is a database structure on top of your HDFS, and the data is stored in columns here. You store the data not in proper tables, but the tables where you have only columns. You don't have rows. All right. And Zookeeper, these are all for your administration works to manage what data is stored in what node and things like that. Okay, and there is a Spark in memory. There is something called in memory available from Spark onwards. It's not that the data can be stored only on the storage. Okay, and you can also store the data on memory. Okay, when the data is in memory, it is faster than disk. Usually in HDFS, the data will be in disk. Okay, but when you process the data in Spark, you can choose to process in memory. What happens is the data is in memory, and whatever process that it takes, then the data is put in the memory, and then for further usage or the further processing, the data doesn't have to be looked upon the storage. Instead, you can look at the memory. Okay, to make it clear, looking at the memory is much faster than looking at the disk. When it comes to huge data as well, it is the same. So that concept is used in this in-memory data flow engine. All right. And Kafka is used for the live streaming of information. It's not that we have to first dump the data, and if we have to look at the data later. No, if you want to process the big data then and there, real time, you can use Kafka and Storm. These are some streaming options that are available in your Hadoop. All right. And Solar and Lucene, these are for searching and indexing, which is very similar to your search. You can just search for the words, you can search for some phrases, and you can actually do some you can extract the information from there. Okay, Uzi for scheduling. See, for example, how I can use Uzi is, if I have a process where my data is in HDFS, and first I want the data to be converted into tables. Okay, so first I want to be in Hive tables, so that would be the first step. And after I have the data in Hive tables, I want to move it to my Spark. That would be my third step. Then after I move it to my Spark, I want to extract the filtered information or the processed information for analytics. So here, if you see, there are 4 steps involved. First, taking the data, okay, and then converting to tables, and then taking the information that I want to put in Spark, and then taking the processed information for further analysis. So this can be organized into a set of jobs using Uzi. This is used to schedule. So you can schedule it as jobs. So one by one, it gets executed automatically. Okay. And there is something called Flume. Okay. Flume is used to bring data from different web sources to your, you can bring different data from web sources to your Hadoop. Okay. And Scoop is to bring structured information to your Hadoop, and you can also export structured information, structured data from Hadoop to your RDBMS. Scoop is basically used for relational data or structured data transfer, and Flume is used for unstructured data transfer. Okay, so these are the different components that are, and Yarn is yet another resource negotiator, which is used for resource management, to allocate resources, to see which resources are used and what process is being happening, and whether the map reduced jobs are successful, and what, so all these information are taken care of Yarn. All right, so this is the Hadoop ecosystem, and these are the different components, and as we speak, there could be more components getting added as well. Okay, I wouldn't say that that's it, only these options are available. No, if you go to the Hadoop Apache .org, you can see so many projects that are available, that are still on progress, that are available. Some projects are already um, deleted. So many options are available. All right, so that's about the Hadoop ecosystem. Here is a definition of what we saw. Okay, a quick recap. Okay, so as I already told you, all the definitions of these can be found in your Apache website. Okay, and these are the different definitions that are available for you. Okay, Apache, what is Apache Pig? So as I told you, to analyze the large data sets using the scripting language, and here using high query language, as I told you, it's a data warehousing tool. Okay, and Spark is an in-memory data processing engine. Okay, so it has the options of streaming, machine learning, or do SQL as well. And comparatively, it is fast, where, when you compare it with MapReduce. And HBase is the NoSQL database, which helps you to store unstructured and semi-structured data. And it is a database, so it allows you to do a read-write access, unlike your HDFS. So this is about the Hadoop ecosystem. And with this, we come to the end of the session. So firstly, thank you so much for patient listening, and all the best. Thank you so much for your participation.